All right, so in this problem, we are looking at a pulley system. This specific problem would be called Atwood's machine. So what we have are two masses connected to each other with this rope going over a pulley. We have mass 1 is 1.73 kilograms, and mass 2 is going to be 5.86 kilograms. And it wants us to find the acceleration of the system when it is released. So this is still going to be a forces problem. So we have Newton's second law and Newton's third law. So what I'm going to do here is I'm going to just redraw this, but instead of redrawing it as them being connected by this pulley, I'm going to draw them separately so I can draw the force diagrams. So we have mass 1 here, and we know that there's going to be some tension applied to this string, and that there's going to be the force of gravity pulling it down. We also were given extra information in this problem. We know that when these are released, we are going to have a net acceleration up on this first mass. And even if they hadn't given us these acceleration arrows, we would know just from looking at the masses of each of the objects that if this was at rest and we were to let it go, mass 2 would start to drop to the ground because it is heavier than mass 1. So this is my force diagram for the first object, and I'm going to go ahead and create a summation of forces for it. So we don't have any x directional motion here, so I'm just going to create the summation of forces on mass 1 is going to be equal to the tension force plus my force of gravity, and it will result in some acceleration of mass 1. The next thing I want to do is I want to include the directionality here. So I know that my tension force is going to be in the positive direction, my force of gravity is going to be in the negative direction, and my total acceleration of this object is going to be in the positive direction. The next thing that I want to do is I want to replace my force of gravity with mg. The reason that I do this is because if I think about Newton's second law, force is equal to mass times acceleration. And I think about what we already know about acceleration due to gravity, negative 9.81 meters per second squared. I can take my gravitational acceleration and break it down into directionality and magnitude, right? My negative is my directionality, and the 9.81 is my magnitude. This acceleration is equal to negative g, where this is my direction and g is the magnitude, 9.81. Because I already incorporated my directionality here, I have to replace fg with mg, right? This value now has to be only magnitude, right? Because I incorporated my directionality already. So I'm going to replace this force of gravity with mg, where g is just the magnitude of the acceleration due to gravity, and this will be equal to m1a1. The next thing that I want to do is I'm going to want to figure out what's happening with this other block. That's because my tension is unknown and my final acceleration is unknown. So when I have two unknowns, I need to solve a system of equations, meaning I need a second equation. So I have mass 2. Mass 2 still has tension on it, acting upwards. This tension is due to the weight of the other object. It has some force of gravity pulling it down, and we know that its acceleration is going to be going in the negative direction. So now I'm going to create a summation of forces for this second object, right? So I have tension, I have a force of gravity, and it's going to equal some acceleration, right? At this point in time, I don't have directionality incorporated here. I just have a summation. So now I need to incorporate my directionality. My tension is still going in the positive direction, but now my force of gravity is pulling down, and I have a negative directionality for the acceleration of this object. I'm going to, sorry, I forgot to note that's M1. I'm going to now replace my Fg with the mass 2 times gravity is equal to negative m2a2. So in this situation, I also have the unknown tension and the unknown acceleration. I've already incorporated the directionality of my accelerations in equation 1 and equation 2, meaning that this a1 and a2 are just the magnitude of the acceleration, right? This is not directionality, there's no vector sign, this is just the magnitude. Because these objects are connected together, I know that the magnitude of acceleration 1 has to be equal to the magnitude of acceleration 2 because they have to move together. One is not going to have a faster magnitude of acceleration than the other one will. So in order to find what A1 is, or what A2 is, or let's just call this now our acceleration, I'm going to rewrite equation 1 and equation 2 so that all I have is tension on the left-hand side. So tension is equal to M1, and I am going to group acceleration and gravity together, right? So all I did was I moved this over to the right-hand side and then I pulled out that mass because that is a shared mass between those two components of the equation. So this is now my new equation 1, and my new equation 2 is that tension is equal to m2 times g minus a. This has the minus sign because I have the minus sign on the right-hand side. If you need to work out the extra steps between that, please do so if it makes more sense to you. So now I have two equations, two unknowns. I don't want to replace the a's because that's what I'm solving for. So I'm going to replace the t in my second equation with this m1 times a plus g. That's because this tension, the magnitudes of these tensions are going to be equal to each other. So this means that I have m1 times a plus g is equal to m2 times g minus a. It's going to be easier for me to isolate a if I redistribute this. So m1a plus m1g is equal to m2g minus m2a. So the next thing I want to do is I want to get the a's all together on the left-hand side. This means I'm going to move m2a over to the left-hand side, and I'll move m1g over to the right-hand side. So this will give me m1a plus m2a is equal to m2g minus m1g. The next thing I want to do is I want to pull the a's out on the left-hand side. So a times m1 plus m2 will be equal to, and I can pull this g out, g times m2 minus m1. The last thing that I need to do here is I need to divide both sides by m1 plus m2. This will give me the acceleration, right? This is my magnitude. Keep this in mind. This is my magnitude. This doesn't have directionality. I have no vector sign here. So my acceleration is going to be g times m2 minus m1 divided by m1 plus m2. Now I need to plug in the values. So acceleration is going to be 9.81 times, I'm going to put a big bracket here. The mass of 2 is 5.86 minus the mass of 1 is 1.73 divided by 5.86 plus 1.73. And I'm actually going to do this calculation in multiple steps so that I do not end up with a calculator error. It takes a little more time, but on something like an exam, it's better to do extra steps so that you know that your error is not a calculator error, right? And you don't have to worry that The solution you got is incorrect because of something stupid, like your calculator not understanding PEMDAS. So 9.81 times 0.544, and this means that the magnitude, right, my magnitude of the acceleration is going to be 5.34 meters per second squared. So if I wanted to be more specific about this, I could say that the acceleration of object 1, we know is moving in the positive direction, has an acceleration of 5.34 meters per second squared, and acceleration of object 2 is going to be negative 5.34 meters per second squared because it is moving in the negative direction.